All right, guys, so when we talk about projectiles, last time we talked about Galileo Galilei. We talked about him dropping things off of the Leaning Tower of Pisa. And we said that gravity affects everything at the same rate. And that rate is 9.8 meters per second squared. But now we have a different question. Same scenario, but different question. If we were to drop one object and throw another identical object horizontally, which one will hit the ground first? So we want to know, basically, up here, what he's thinking is, does throwing a ball horizontally affect how fast it takes the ball to reach the ground? So let's look at what's going on here. We've got two balls. One of them we're just going to drop. The other one we're going to throw. So when we're at the very top right here, both of these have zero vertical velocity. Right here, their initial velocity for both of them is zero, right? Going up and down. Now, we're going to throw one, and one we're going to just let drop. On the one we throw, after we throw it, the only force that's working on this is gravity. So after we throw it, the only force working here is gravity. Because we're going to disregard air resistance to make this a little bit easier for us. So this is our vertical velocity right here. And this one's over here. And then I'm going to highlight horizontal in red, and I'm going to do my best to keep these colors separated for y'all to make this easier to see the whole time we work through projectile motion. So there's our horizontal velocity. This is the initial velocity from when we threw this one out. So right here, the magnitude of the balls, if you look, this is even, and this one is equal to this one, and this length is equal to this one. So what that shows us is that the magnitude of the balls, vertical velocity, increases at the same rate, which is gravity, so 9.8 meters per second squared, because of gravity. So gravity is what lets this one and this ball have the same vertical velocity throughout. The only thing that's a little bit different is this horizontal velocity. And what you'll notice is as you travel down, this horizontal velocity never changes. It's always equal. So this one is equal to this one. That one is equal to that one. It's always the same. The only velocity that changes is this vertical velocity, and that changes because of gravity. So over here, with Galileo, his question says, does throwing a ball horizontally affect how fast it takes the ball to reach the ground? And the answer is no. It does not. So we can say without a shadow of a doubt that horizontal velocity does not affect vertical velocity. They are independent of one another. So what is the definition of parabolic motion or projectile motion? So the definition of projectile motion, this is what a projectile looks like, right? It makes this really pretty arch. So we know that when we have a projectile, it makes a parabolic shape. We also know that projectile motion is the motion of an object due to gravity. Because gravity is the only force acting on it. After that initial velocity, the only force that's acting on this is going to be gravity. All right, so let's think about what are some different things that might involve projectile motion. Now that we know what projectile motion is, it's when we launch something or throw something. What are some different situations that might involve projectile motion? The first one that comes to mind for me is soccer. I just went to a soccer game the other night. Please ignore my horrible drawing of a ball. But kicking a soccer ball would be parabolic motion. A football would be parabolic motion. When that football player throws that football or makes a pass, jumping up and down. So jumping up, a frog jumping, any animal jumping, a kangaroo. If you like war or you like anything like that, launching a cannon would definitely be projectile motion. A paintball gun, an airsoft gun, any of that's going to involve projectile motion. What goes up must come down eventually. So let's think about it. We have a snowball fight with two siblings that are tossing snowballs. If the sister launches a snowball at her brother, what point does the snowball have no vertical velocity? So at what point, after she throws that snowball, is it going to stop reaching vertical velocity? And it's going to have no vertical velocity at its max height. Remember, we used that before. We said that when we dropped something or when we threw something straight up, right before it started heading back down, it had a vertical velocity of 0 or a velocity of 0. And we used that before to plug it into our problems. And we're going to use the same thing again. So right as that projectile reaches its max height, right there, its velocity is 0. And then it says, if the sister launches the snowball at her brother, at what point does the snowball have the same speed as it did when it launched? So the speed is the same when the snowball is at the exact same height as the launch height. And those are just some critical thinking questions to get you going. Today, so when you think about projectile motion, to sum all of this up, when we think about projectile motion, we need to think about throwing something or launching something. And the only force acting on it after we throw it or launch it is gravity. And gravity pulls everything down at the same rate. So regardless of the fact that we projected it or threw it, it's not going to affect that vertical fall of the object. And that horizontal velocity is never going to change. It's going to remain constant throughout. Because after we throw it, we're no longer adding or taking away a horizontal velocity from it at all, because we're disregarding air resistance. So an object in motion stays in motion. All right.